first thing up on top, our exponent, is the smaller number that's written above. So when we look at that exponent, what does the exponent, if we are looking at that, what does it tell us? Yes,
How many times are going to multiply the base number?
How many times, I agree, how many times you multiply that base number. So when we are looking at the exponent, it tells us that we need to have 3/8. How many times you multiply the base? And in this case, our base is the 8. And the 8, if we are looking at that, is the number that's being multiplied. So when we talk about our base number, this is the number that you are multiplying. So in this case, we had 3/8. And this whole thing is called the power. So when you have a base with an exponent, so in your homework, if they say leave your answer as a power, that means when we're talking about a power, that means I need to have a base and I need to have an exponent. Okay? So if I ask you to leave your answer as a power, that means I want it as 8 to the 3rd and I don't want you to multiply that out. I want you to leave it as 2 to the 5th, and I don't want you to tell me what that's equal to. So it says, what happens to the base if a power is negative? So if we are looking at it, what happens to the base of a power if it's negative? So if our power is negative, that means if we look at that, we are going to be thinking about different from negative exponent and if the base is negative. Now, if I have a negative base and I have -2, what's that? If I have -2 to the 3rd power, right? That means how many -2's? 3. And that would equal a -8. But if I have -2 to the 2nd power, now this is when it comes out to be -2 times -2. Which is positive 4. But sometimes you have something written like this, where you have negative and then you have 2 to the 2nd. And this is very different than this one, okay? -2 to the 2nd comes out to equal 4. This -2 to the 2nd means actually -1 times 2 to the 2nd. So because there's no parentheses, so you have to be smarter than your calculator. If you put this into your calculator, -2 to the 2nd, you should probably get -4. And if you meant to square a -2, then it should be 4. This one is going to be -4. What happens when our exponent is negative? That's what we are soon going to be discovering. Some of you might remember when you have a negative exponent. On your calculators, if you see a calculator and you have this -1 key, x to the -1, and some of you, that key might even look like this, 1 over x. These two mean the same thing on your calculator. It's a wonderful button. Why don't you take out your calculator right now, and let's see it. And then hit that button. I think I have to get on mine. I actually have to put the 4 first, then I have to put 1x. What word does mine say up there? Reciprocal. So negative exponents, what they really do, people think they give you negative numbers. They give you reciprocal. So put in 0.5 and then hit that button. What should the reciprocal of 1/2 be? 2. So that button is really useful when you're doing like a long expression or you're doing things, but that's what that means when you are looking at it. So it means reciprocal. So as we watch this short little video as we're going to look at, then we're going to talk about what we were just looking at with the positive and negative as we are looking at that. So if it is positive or negative, what's happening to that answer? Just base to an even power. When we just looked at our last one and we took -2 to the 2nd power, we got 4. If we are looking and we take -1 and you take it to the 4th power, how many -1s are we taking times each other? 4. Should be positive or negative?
positive.
Should be a positive 1 when we look at it. So when we take a negative base to an even power, as we look at that, our solution we think should always be positive. If we take a negative base and we are going to take it to an odd power, doesn't matter what number is in that negative base. If I have negative 1 to the 3rd, if I have negative 1 to the 5th, if I take a negative number to an odd power, my answer is always going to come out to be negative. So negative base to an even power positive, negative base to an odd power is always going to give us a negative number. So we're looking at evaluating negative 1 to the 15th power. I'm multiplying 15 negative 1 together. Should it be positive 1 or negative? Should be negative 1. This is the one where I was talking about where it's a little different. When you look at this problem, what this really means as I'm looking at this is it means negative 1 times 4 to the second. Negative 1 times 4 to the second is going to give me a negative 16. Versus, if I ask you to write down negative 4 and we have to the second power, that one equals 16. This one is equal to negative 16. So making sure you know the difference as you are looking at that. And then that last one, as we take a look at it, if I'm taking negative 10 as you were writing down, times itself 3 times, we should have positive or negative 1,000? Negative 1,000. Okay? On the top of the next page, it asks us to complete this table and look at a pattern. Now, you should have your calculator, but you probably don't need it. 2 to the 3rd, we know is what? 8. 2 to the 2nd, 4. 2 to the 1st, 2. 2 to the 4th then should be what? 12. Careful. Taking 2 times 2 gives us 4, times 2 gives us 8, times 2 gives us 16. So now each time if we look at this pattern, because it says, well, what's the, describe the pattern in the 2x. What does it look like at this point as I go down the table? We are dividing by 2. As I go down the table, we're going to divide by 2. So 2 divided by 2, 1. 2 to the 0, and if you check it on your calculator, 2 to the 0 is 1. I am going to ask you to not write them as decimals. It says keep your answer as a fraction, not decimals. So this is telling us 1 divided by 2, if we keep that pattern going, is 1/2. 1/2 divided by 2 is 1/4. And if we think about this pattern, this is telling us to take 1 over 2 to the second, which is 1/4. If you put it in your calculator, you should get a decimal. So if we are looking at the 10x, at that column going down, easiest thing with 10 to a power is it's a 1 followed by that many zeros. So it's pretty easy if you think of starting with 10 to the second. 10 to the second is 100. 10 to the first is 10. 10 to the third is 1,000. And this should be 10,000. Right? So again, that pattern, if we are going down the table, what does it look like is happening? We are dividing by 10. Someone said moving the decimal back one place. Yes, but we want to keep it as a fraction. So 10 divided by 10, 1. 1 divided by 10, 1/10, and then 1/100. Okay? Exponents and 0. Negative exponents tell us to take the reciprocal of the base and then use repeated multiplication. So on your homework tonight, when you have 2 to the negative 3, I want you to rewrite it as 1 over 2 to the 3rd power. Now, the question is, could I write that? What is 1 to the 3rd power going to equal? Just 1, right? And then 2 to the 3rd power would be 2 times 2 times 2 gives us 8. Now, if I ask you to leave it as a power, this is where you're going to stop. You're going to leave it as 1/2 to the 3rd power. If I don't ask you to leave your answer as a power, you would give me the answer, which would be 1/8. So 2/7 to the negative 3. If we're leaving our answer as a power, we take the reciprocal, right? That's all that's telling us to do. Reciprocal, and we make this a positive. So it changes from negative to positive, okay? On every quiz and test that we take, and as you go forward, I am always, except for scientific notation, going to have you always give me all of your answers with positive exponents. I don't want any negative. So if you leave it as a negative exponent, it's going to be marked wrong. It's going to be points off as we are looking at that. So 7 to the negative 3, if we are thinking of that means 7 over 1 to the negative 3. So we're going to take the reciprocal of 7, which is 1/7, to the third. This would be our answer as a power. So if I said leave your answer as a power, you'd stop at this point. If I said simplify it, you could put this in your calculator and get 7 to the third power is 343. I don't want you to tell me the decimal. It's really easy to put 7 to the negative 3 and tell me that it equals 0.000 whatever. I don't want it that way. So here's the rule. If you have a negative exponent, you can rewrite it as 1 over a to the m. So anytime you have a negative exponent, but that goes both ways. And so what I want you to also put with this one is we also want to write down that if I have 1 over a to the negative m, okay? So if I have 1 over a to the negative m, that is going to be equal to a to the m, taking the reciprocal, over 1. So anytime you have a negative exponent, you move it from the numerator to the denominator, it makes it positive. If it's negative in the denominator, you move it to the numerator, and it makes it positive. So you're just kind of switching those back and forth. So then it says, when the exponent is 0, the answer is always 1, for any number other than 0. When you have 0 to the 0 power, that answer is also 0. So anything to the 0 is equal to 1. You would think this would be easy to remember and people wouldn't make that mistake, but if I have 4 to the 0, people will tell me 4. 4 to the 0 is not 4, it's 1. Anything to the 0, everything to the 0 is 1. So, top of the next page, we are simplifying these, and then we're shortly going to get you working on your homework. So, first thing we want to do is we want to write it with a positive exponent. So we're going to rewrite that as we look at the problem. It was x to the negative 9, and if it helps you, put that in a fraction like over 1. So now we're going to do the reciprocal, which gives us 1 over x to the 9. Now, if you write your x to the 9th so it looks like this, I'm probably going to mark that wrong, right? Because that doesn't even look like an exponent. So make sure that you're kind of clear. So this next one, I would like you to try the next two, and then we'll kind of check as we look at that. Aiden, what do you have?
I have
n over 3.
Uh-uh.
And to the
Third
power. Yes.
And 1.
Could you have it over 1? Yes. Could you have just left it as n to the third? Yes, I would take either one of these ends. Okay. Helen, as we're looking at the next one.
A to the 3rd over 2.
A to the 3rd. Is 2 to a negative exponent? No, we're going to keep the 2 exactly where it is. So we're going to have 2a to the 3rd. And if you wanted to write it over 1. So the only thing you're moving, and this is probably, you're not the only one that made this mistake, because I've had a lot of people erase it and looking at this, is it's really easy to go, oh, move the negative and make it positive, and then I must move this one. Only move this if it's negative. Could you have left the answer as 2a to the 3rd power? You could have left it that way. Okay? So this next one, let's put that whole thing over 1. So, Laura, if I'm starting, do I need to move 4? To the denominator? No? No, we're going to keep the 4. So we're going to start off, got 4 where it's at. Tristan, what do I know about a to the 0?
That's 1.
Equals 1. So I have 4 times 1. I got that c to the negative 3, Caleb, which I'm going to do what? Put it in the denominator, so it's now c to the 3rd. And then Brooklyn, b's to the 1st power, right? There's no power, so it's b to the 1st. What am I doing with that? Keeping it on the top. So if I was looking at this answer, usually we don't put down the 1, but that would be 4b all over c to the 3rd. Because 4 times 1 is 4, right? So we're looking at that next one. Jack?
Oh, sorry. So you move the n to the power of -5 down.
Okay. And it's now n to the 5th.
Positive.
And m to the 2nd. What goes on top?
1.
We're going to do 1, because it's like taking the reciprocal. Now, the question is, does it matter if you have this answer, m to the second, n to the fifth? Same thing, right? Because we're multiplying this base to the power of 5, I just got to make sure I have n to the fifth times n to the second, and the order doesn't matter down here when I'm multiplying. Okay, question?
How come we're multiplying instead of adding?
So when I look at this n to the negative fifth, so all of these, this one makes sense that it's at multiplication, right? So if I'm looking at this one, I might have first rewrote it as 1 over n to the negative fifth becomes n to the fifth, right? And then if I wanted to think of this, this is times 1 over m to the second. So when I took the reciprocal of this, I'm just taking this part separate. So if I wanted to think of it as even n to the negative fifth, right, over 1 times 1 over m to the second. So it is still multiplication. And then we get into more rules tomorrow when we look at that. And then you're going to have the story type of situation in your homework, okay? So most of the questions are going to be like that first, those last 5 questions that we just did. And then you're going to have something like this. And we say the population of marine bacteria doubles every hour under controlled lab conditions. The number of bacteria can be modeled in the expression where H is the number of hours after they started measuring the population. So 1,000 times 2 to the H, because it's doubled. So 2, the reason they're using a 2 in this equation, right? The reason for a 2 is that they tell us it doubles. So doubling is taking something times 2. So we're asked to evaluate it when H is 2, H is 0, and H is negative 3. When H is 0, what's going to happen? Let's go to that one first. 1,000, right, times 2 to the 0. That's going to end up being 1,000 times what?
1.
1,000 times 1. So if we are looking at that answer, when I take a look, didn't you guys do exponents last year in pre-algebra? I taught pre-algebra a couple of years ago. We had one with a really large class of sophomores. I taught it then, so I can't remember, but I thought we did. So the assignment is 15 to 36 all. And so I will leave this up here for those of you that maybe didn't have your textbook.
Thank you.